Did you know that the general advice to reduce table salt in order to lower blood pressure doesn't work equally well for everyone? In this video I'll explain why and what role your genes play in this. Salt, or more precisely sodium chloride, is essential for life. It is responsible for a multitude of processes in the body. It helps regulate the water balance in cells, supports muscle and nerve function, and maintains a stable blood pressure. It is also a crucial component of electrolytes, which help transport nutrients and oxygens into the cell and remove waste products from them. A lack of table salt can lead to issues like dehydration, muscle weakness, and even cardiovascular disease. However, as is often the case, there can also be too much of a good thing. An excess of table salt can cause kidney damage, osteoporosis, and gastrointestinal problems, but it's primarily the influence of table salt on blood pressure that this video is about. This is because your genes have a say in this matter. When salt is consumed through food, it enters the bloodstream. The body's natural reaction would be to dangerously raise blood pressure. The AGT gene comes into play next. It indirectly interacts with table salt, preventing blood pressure from rising dramatically. The cardiovascular system is thus protected from high salt consumption. But things are different for carriers of defects in the AGT gene. In this case, the gene offers no protection and blood pressure is significantly increased by excessive table salt consumption. The only solution for people with defective genes is to reduce their table salt consumption. Instead, dishes should be seasoned with spices and herbs to protect the cardiovascular system as much as possible. But how common are such genetic defects in the AGT gene? Like most human genes, everyone has two copies, one inherited from the father and one from the mother. About 18% of the population has two functioning genes and can handle table salt well, with little change to the blood pressure. 47% have one functioning and one defective AGT gene, making them more sensitive to table salt. The remaining 35% have two defective genes and are highly sensitive to excessive table salt in the diet. Finally, an important point. Too much table salt is of course unhealthy even with optimal genes, and everyone should pay attention to their salt intake. However, research on genes has shown that it is even more unhealthy for some people than it is for others.